So I've only got 20 minutes or so to just give you an introduction, I suppose, to integrated water management and resilience. So hold on to your seats. So what I want to do this afternoon, is to pick up two elements. One is about resilience. One is about integrated water management. And I'm just posing a question about, are they the same thing or are they different? And maybe we'll come back to that. So I want to look at some of the drivers of change that are driving integrated water management approach, the why. Some examples, kind of the what, and water and integrated water management, the kind of so what, effectively, at the end. So a little bit about Arup. We're an engineering consultancy based in the UK. We work across many engineering disciplines, from transport, energy, buildings, infrastructure, and water is a significant part of our business. We're based across the world, and we have a community of engineering where we're able to learn from each other and bring some of that value to wherever we're operating. I'll just quickly give you some reference projects that we've been involved in over the years. So some of these are well known, some less so. Sydney Opera House, Maritime Museum in Osaka in Japan. A composite shot of some of the things that we're quite well known for: tall buildings across the world, buildings close to home. A little bit really about water. This is an urban water environment in Bradford, regeneration project. Some mega projects in Singapore, wastewater treatment plants in Hong Kong, and close to home, wastewater treatment plants in the UK. So that's really just to give you an idea that we cover a wide breadth of engineering topics. So the drivers of change, and I've just gone back to the World Economic Forum, which met earlier this year in Davos, and just hunted around and found a few references to water. So I've highlighted them here in terms of the likelihood and impact. And you can see that many of the economic risks facing the world have a water element to them. I think you'll see as we work through some of these slides how we might actually start to mitigate some of those issues. So as a firm, we maintain a foresight and innovation team within many of our offices who give us the opportunity to do a deep dive into the drivers that are pushing ahead, perhaps 20 or 30 years ahead, and looking at how that might impact in terms of our design for today. So just pulling through some of the key themes in terms of water drivers. You probably all recognize these in terms of population growth, extreme weather events, urbanization. I'm sure there's some others to go at, but what I'm trying to say here is that if we take a new approach, perhaps we can mitigate some of these key drivers of change, especially where they impact on water. So we think about urbanization, important global aspect. We're all moving into urban environments, and therefore the urban water environment becomes that more important. So we've now hit over around about 50% of the world's population living in large cities, again larger. They're actually having more and more impact on their water catchments. So we need to think about ways of mitigating that. So looking at a city and some of the water hazards from global climate change issues, too much water, too little water, groundwater issues, extreme weather events. Again, you'll see that many of the impacts from climate change are being felt through water, and that's a very important thing to remember. So I've just put up what I feel might be a definition. I'm sure there's plenty of other definitions out there for resilience, and I've picked up a key couple of things there. It's about the ability of systems to recover following shocks and stresses. So when I say a shock, that may be an extreme weather event like a flooding event. Stresses are more longer term acting, and that might be sea level rise. So again, resilience comes into that, and we need to consider in our designs and how we move forward, how we might build resilience into our water systems. So whenever I think about water in the urban environment, I actually think about the wider catchment issues. I think about the catchment that our cities depend on and wider. So again, if you consider this notional catchment, again, you'll see all the way through the catchment the impacts and touch points for water. There's touch points between different engineering systems like the energy systems and water systems. There's touch points between transport. There's touch points between how we live our lives and the wastewater that we generate. But if you break that down and just perhaps you can consider in the middle there as key demanders are us, the way we live our lives, buildings and users. We're supported by infrastructure, grey, which in turn is supported by the blue-green environment. And what we need to do is to work out a way of optimizing that relationship. Another way of thinking about it is we often consider potable water as different from wastewater, is different from stormwater, is again different from non-potable water. But if we take an integrated and optimized viewpoint, we might come to a different solution. And instead of treating them as four discrete systems, if we think about where they overlap, there's opportunities to optimize those, making better use of your wastewater locally, better use and retention of stormwater, and reuse locally. I've just pulled out a few of some of the techniques that we use, or some of the impacts there in terms of the urban realm. SUDS, water supply, water scarcity, all of these things are impacted by our approach to water management in the urban environment. And so what are some of the benefits that I perceive in terms of an integrated approach? So once we start optimizing our solutions, we're going to have lower impact developments. We're going to utilize green infrastructure in a better way. We're going to minimize the cost of upgrade and perhaps avoid or defer infrastructure costs, either at the treatment or the conveyance, and all the disruption that comes with that. There's potential cost savings to be had, and perhaps, most importantly, increased resilience. So I've just picked up a few things about thinking about greening our cities. Perhaps this is a vertical example. These are new cities or buildings where you've got the opportunity to start from scratch, and that's not always the case, and we'll come to that in terms of retrofit shortly. So if you then take it down to what that means at the community level, is that effectively people live in cities, and we need to pull in people into that conversation. We've started to work on a series of projects looking at community involvement in building that water picture, getting people excited at the household, the street, the community level, and having conversations around water with a view to having them co-design solutions so that they will be better maintained and better loved in the future. And some of those projects are already coming to fruition. In New York, we've looked at greening our streets, and we've used technology to help bring that to life, so we can actually look at a streetscape and imagine what that might look like in terms of greening it, and then turn it into reality. And that's a great way to bring communities along with you. I thought I'd just quickly pause and just think about other aspects about integrated water management, perhaps that don't get discussed as much. But actually what we're thinking about is a circular economy here. So once we look at natural systems and making them as natural as possible, then you begin to imagine we can live in a much more sensitive and circular economy fashion. But also we could do more with the systems we've got. So if we look at our sewers, we can extract value out of our wastewater, we can extract nutrients from there, but also we can extract heat, and that's already been done in parts of Europe, and providing thermal networks around the city. So bringing it back to closer to home, just a really quick case study about some of the challenges in London with population growth, aging infrastructure, and infrastructure hotspots where already systems are at their conveyance capacities. So we know that London is growing and set to grow even further. We also know that we're having more and more frequent extreme weather events. We also know that these growth areas are being driven into areas of opportunity. So you can see the areas for London, and many of you will know these areas from personal experience. But if you overlay some of the hotspots, you'll suddenly see that actually we haven't got much drainage in those areas where we need that growth. So actually we've got to come to a different solution than the one that we typically build our way out of problems. We've taken some of this thinking to Nine Elms in Battersea. We're looking at the development there anchored around the American Embassy. So that's effectively 24,000 homes being built in what is effectively a brownfield site, bounded on one side by Battersea Power Station and Vauxhall on the other end. That's what it looks like today. You can see the water demand there at 1,000 cubes a day, going up to 8,000 cubes a day. So where's all that water going to come from? Well, can Thames supply it? Can Affinity supply it? Well, actually, they're constrained both in terms of the water availability, but also the infrastructure that carries that water. So if we can bring an integrated management approach to that and better use stormwater on site, displacing potable, if we use non-pot on site, displacing potable, we've got a much more resilient and robust solution. So in terms of that thinking, the way we think about that, we've got an area of interest and we can apply the engineering know-how to that, minimizing and optimizing against the boundary conditions, in this particular case, congested infrastructure in and around Nine Elms. We bring in some of our thinking in terms of rainwater harvesting, stormwater attention, the use of SUDs, green ribbons. So bringing that into the heart of the design from the very outset. So before anything gets built, bring in a water strategy, which is very important to get right from the outset. We've got ways of communicating that to stakeholders like developers, local authorities. Here we're just showing how the build out works and what the impact over time on the consumption. So really that's given early insight to the water utilities that if they do nothing about it, business as usual, they've got this headache approaching. So this is quite a lot to take in, but really I just want to show here that we're effectively moving from a sewered city, drain city, and perhaps the more we can integrate the water to the water cycle, we move across to a water-sensitive city. So we've just mapped on a few cities around the globe where we've been working. Manila is effectively a sewer city. Sao Paulo, a drain city. The UK, maybe a sort of waterway city. Sydney's moving forward to a water cycle city. And we've got to move and shift cities along that scale. And we have tools to help us along that. And we've created a Water City Index to look at all the impacts, including governance of these systems and how they would operate. We brought our tools and thinkings to various cities around the globe. And that, because Arup is owned by its staff, we're very keen on actually making our knowledge public. So we publish everything we do. We put our thinking out there, and if anybody's interested in any of these documents, happy to share them. There's plenty more there. And we put them out in the public domain so we can all move forward as an industry, as a sector together. And then finally, there's a role also for technology, and we've begun to look at where the needs of the industry and how we could articulate that. So we've created a portal. Again, it's a free-to-use portal called Venturi Portal. It articulates the water needs across the globe and locally in the UK. So it allows innovators to start looking at what needs may be in Vietnam or Birmingham or South London and say, actually, have I got technology that can help with those needs? So feel free to have a look at that Venturi portal. The website is venturiportal.com. Let us know what you think. We launched it 9 months ago, and it's growing from strength to strength. Again, if you've got technology or ideas or even a problem, let us know and we can promote that to a global audience. So I just want to leave you with that in terms of resilience, because I think effectively all we're talking about this afternoon, you can bring it back to enhancing resilience. So I think when we talk about water, we need to be thinking about systems resilience.